Hello everyone, welcome to Antibuddies. In this tutorial, we're going to learn about parallelism and how to run a parallelism test in GraphPad Prism. If you're here just for the GraphPad tutorial, please skip ahead to the last section. Let's start with what is parallelism and its applications. Here we have two curves. Any two curves can be considered parallel if one curve can be obtained by linearly scaling the second curve on the x-axis. Here is the dose response curve for drug A in orange and drug B in green. The response could be anything, and these doses could be any arbitrary values. You can see how the curves look parallel. Mathematically speaking, if the curves are parallel, I could move the green curve right or left, and it would scale linearly, and it would stay parallel wherever I scale on the x-axis. Now here is drug C, which does not look parallel. That means if I did scale it on the x-axis linearly, the distances between each points would change non-linearly, and that's not good. This kind of parallelism test has many applications. It allows us to compare curves and by proxy compare materials like drugs. We can ask, are the two drugs similar? We can use this parallelism assessment for drug relative potency assessment, for matrix comparisons, and for establishing comparability in biosimilars. The examples I just showed in green and blue were stark enough that we could eyeball it and say whether the curves are parallel or not. However, in real world, things are not that black and white. So we need to use statistical tools to answer questions regarding parallelism. Here is a decision tree that I borrowed from the good folks at Quantix. This tree shows all the parallelism tests that are commonly used and when each test should be used. For today, I'm just going to focus on the F-test part. We can look at how does the F-test work and how we can implement this in GraphPad. If you already know the answer to this or don't want to bother about learning what the F-test does, you can just skip ahead to the GraphPad tutorial section. If you have decided to stay, it is important that you are familiar with all these concepts. If any of these terms sound gibberish to you, I want you to take a deep breath and go read about them or just skip to the GraphPad tutorial part again. With that, here is a quick summary of the F-test for parallelism. We start with a null hypothesis. In English, it states that the curves can be considered parallel. In mathematics, it states that the extra sum of squares obtained from fitting independent curves and a constrained curve for drug A and drug B is not significantly large compared to the sum of squares error obtained from the independent curves. The independent curve, or the free curve in this case, is made by looking at those response data from drug A and drug B independently. The constrained curve is made by treating the two data sets as a combined single data set and constraining all parameters of the curve except for the parameter that corresponds to the dose. For instance, if the curve follows a linear function, we will use the x-intercept as the dose parameter. A sigmoidal function like the 4PL will have its inflection point, commonly known as the EC50 or IC50, as its dose parameters. So again, in the constrained curves, we are constraining all parts of the curve except the dose parameters. Those dose parameters stay separately for the two data sets for drug A and drug B, but everything else is taken as a single data set. This brings us to the alternative hypothesis. The alternate hypothesis states that the curves are not parallel. Mathematically, we're saying that the extra sum of squares is significantly large compared to the sum of squares error from the independent curves. Just how large enough should this extra sum of squares be? This is a question that we will answer based on an arbitrary significance threshold on an F distribution. 0.05 is a good threshold to start with. And that's what we are going to do in our tutorial today. So let's start building this analysis in GraphPad. Here I have two data sets, one for drug A and one for drug B. You want to make sure that the table type is XY. Now go to Analyze, choose a regression model that you know works well for your data. I will be making a separate video on this topic about how to decide which curve fit model to use for your data. For now, I'm just going to use the non-regression fit using 4PL because I know that works well for the data I'm using. Remember that in our hypothesis test, we were comparing two curves, an independent or a free curve and a constrained curve. Here, we will do that in the Compare tab. One of the curves will be independent, the other curve will be constrained or will have shared data sets, except for the dose parameter. Now we can get to the analysis. The F-test result is out. We have a p-value of 0.1, which is above our significance threshold of 0.05. Therefore, we fail to reject the null hypothesis, and therefore we can continue assuming that the curves are parallel. With that, you can continue with your downstream analysis. And that's all for the tutorial. Let me know if you'd like this kind of video tutorials or if you'd like to see anything more in future. Thank you and have a good day.